Hi students, hope all are going well. In this class, we are going to discuss grade 9 chapter circles. What is a circle? In small classes, we studied the definitions of circle, right? And we have two major definitions of circle. Circle can be considered as two-way. One is, it's a collection of points. Another one is, it's a locus of point. What is meaning of locus? Locus means path of travel. Okay, let us come back. So circle is a collection of all those points in a plane which are equidistant from a fixed plane. Collection is said all those points in a plane which is equidistant from a fixed point. Let us draw one circle. We have a circle. So it's a collection of all points from a fixed point. What is the fixed point? This is the fixed point. That is known as, it's actually center, right? Yes, it's the center of the circle. And collection of all the points around this center. That is circle. So what is that fixed distance from each and every point in the circle to that center? We know that is the radii. This is the distance, right? That is distance and this is the same distance. So this can be considered as radius. Radius is denoted by r. This is the radius of the circle. Got it? At the same time, the circle can be defined in a different way. A circle is defined as a locus of a point from a fixed point keeping a fixed distance. So what is locus? It's a path of travel. Okay, we have our compass. Let us draw a circle. If you are drawing a circle with a compass, you can see the tip of the compass is moving, right? That is a point. Tip of the compass is a point. That is moving about a fixed point. Which point is that point? This point, right? That is our center. This is the center. And we are not changing the radius in the compass. So that fixed radius, that fixed distance, that is our, this fixed distance. This is our radius. So in two ways we defined a circle. What is the first way? A circle is a collection of all those points in a plane which are equidistant from a fixed point. Second one, a circle is defined as the locus of a point from a fixed point keeping a fixed distance. I hope all of you understand the definitions of the circle. Now, let us learn the parts of the circle. These are the major parts of a circle. What are the major parts of the circle? This circle, if you are cutting, we will get two portions, right? That is arc of the circle. And if this is a small arc and remaining, we have big one, that is also arc. So small one is known as minor arc, big one is known as major arc. Okay. Now, if this is the center of the circle, and we know that the center to any point in the circle, the distance, that is known as radius of the circle. And if a circle considering, if a 2 points if you are considered, if you are connecting the 2 points of a circle, that line segment is known as the chord of the circle. That is a chord. Chord is clear? Now, if that chord is passing through the center like this, then that particular chord is known as diameter of the circle. And diameter and radius we have a relation, and we know that this distance is radius. So obviously diameter is the double of radius. We know already, just rewinding. Okay. Now, if a line which is passing through the circle, which is touching at two distinct points, here and here, such a line is known as secant. That is known as secant. At the same time, if the line is just touching only the circle, but it is passing through outside, such a line is known as tangent of a circle. Then the point wherever it is touching, that is known as point of tangency or point of contact. Now, what are things we studied? Arc we studied, center we studied, radius studied, diameter studied, secant studied, and tangent studied. These are actually the parts which is related with the circle. Now, if you are considering circle as a plane region, if you are drawing two radii and one arc, there is a region is created. Such a region is known as sector. At the same time, if a chord and an arc, that also creating a region, that region is known as segment. Same way, if this is a small sector and the rest of the entire portion is a big sector, that is known as major sector and this is minor sector. Same way, this small portion is minor segment and the rest of the portion is major segment. I hope all of you clear all these parts of the circle. Clear? Good. Now, let us come to the first fact which is related with our circle in the chapter circles. What is that? If the length of two arcs of a circle are equal, then their corresponding chords are equal. What is the fact? The length of two arcs of a circle are equal, then their corresponding chords are equal, and vice versa. See, here you can see a circle, and in the circle this is an arc. AB is an arc, CD is another arc. And if the length of AB is exactly same as the length of CD, then the length of the line segment AB, that means the chord AB, and the length of the line segment CD, that means the chord CD, will be equal. This is a fact. Simple fact. I hope all of you understand. Same way, another figure. Let us see the another figure. So here, LM is a arc. XY is another arc. And if two shapes are entirely equal, we are normally telling that they are congruent. Right? So if LM is congruent to, arc LM is congruent to arc XY, then the chord LM is congruent to chord XY. I think this fact is clear, everybody. Right? So these are the basics. First of all, we studied definition of circle and parts of circle. Now let us come back to the first theorem in the chapter, Theorem 10.1 in our textbook. What's the theorem? Equal chords of a circle subtends equal angles at the center. Equal chords of a circle subtends equal angles at the center. Now we can prove this. It's a prove that question. We should know the proof of this one, okay? So this is our circle. Our circle is ready? Then where is the center of the circle? Yes. Here, that is the center of the circle. Oh. We have two chords which are equal. Which are the chords here? We have a chord we can name. What is the name of our chord? AB is first chord. We can name another chord here. That is CD. AB and CD are equal chords. That is given. AB equal to CD. Okay. We know that every prove that question, normally we are following a format, right? What is given and what we need to prove. And if there is any construction, we have to mention what construction we used. And main part, proof. Like that only we are proving. So first of all, given. What is given? The given part, O be the center of the circle. OB the center. What is the name of our equal chords? AB and CD. AB equal to CD, that is given. There are subtending equal angles at the center. So we have to connect to the center. We can connect A to O, B to O, and C to O, and D to O. Okay. Now we have the angle C's here. Angle AOB. We have the angle AOB. That is the angle subtended by chord AB. And what is the angle subtended by chord CD? Yes, it is angle COB is the angle subtended by arc CD. Now what we need to prove here? We have to prove these angles are equal. Which angles? Angle AOB and angle COD. Okay, to prove angle AOB is equal to angle COD. That is what we need to prove it. Any construction we need here? Yes, construction we already made, right? So what is the construction? Construction. Join AO, BO, CO and DO. That we constructed. Now proof. Ready? Every geometrical proof like this, which ideas we are using normally? Congruency. Same congruence idea which we studied in chapter triangles, that only we are using here. For using the congruency, we have to apply any one of the congruence criteria. Let us see which criteria is possible here. Already we have AB equal to CD, right? Now anything is equal in the both triangles? Yes. AO. This AO equal to CO. Correct? Radius of the circle. So this is radius, this is radius. Any other thing? Yeah, yes. BO and DO, that is also radius. So BO equal to DO. Now observe this triangle. If you are observing this triangle, what do you understand from here? That is a triangle. This is the triangle. In both triangles, what we observed here? Here, radius is there, radius is there. This side is equal to this side. Same way, this radius, side. Which criteria? Side, side, side criteria. SSS congruence criteria. Correct? Let us write it. So, from triangle AOB and triangle COD, what are the equal measurements? AO is equal to CO, BO is equal to DO. Reason? Radii of same circle. Radii of same circle. Then what is given already? AB equal to CD. They are equal chords already given. AB is equal to CD given. So, by which criteria? SSS. By SSS congruence criteria, SSS congruence criteria, triangle AOB congruent to triangle COD. Triangle AOB congruent to triangle COD. If triangle AOB and COD are congruent, then what is the relation between our required angles here? These angles here, angle AOB and angle COD. They are actually the corresponding parts of the congruent triangles. So, let us mention, therefore, angle AOB is equal to angle COD. What is the reason? Corresponding parts of congruent triangles, CPCD. That is our proof. So what we studied from this theorem? Equal chords of a circle, subtends, equal angles at the center. All of you understand the proof? Yes, good. Now let us see a small question based on this theorem. We have a circle, right? Okay, in the circle we have two chords which already marked, AB and CD. From AB and CD, what is there? AB equals CD. Okay, if AB, suppose AB is a 10 centimeter and CD, that is also 10 centimeter. Then assume that angle AOB is 50 degree. Then how to find COD? So what is question? Our AB is 10 centimeter, CD also 10 centimeter. Then angle AOB is equal to 50 degree. Then what is angle COD? What is angle COD? Yes, 50 degree. Right? What idea we applied? Equal chords of a circle, subtends, equal angles at the center. I hope all of you understand this topic. We will continue circles chapter in the next session. Thank you.